Hello, hello, math lovers. Today's topic is how to multiply fractions by a whole number. We will practice to multiply fractions and mixed numbers by a whole number. So let's as always, begin with a word problem. Monique has 5 pieces of pink lace, each 2 meters long. What is the total length of pink lace that she has? Well, that's an early third grade word problem. 5 pieces, taken 2 meters each. Of course, she has 10 meters of pink lace. Everything is great. Third grade. Now, let's fast forward to 5th grade. Monique has 5 pieces of lace, each half a meter long. Half a meter long. What is the total length of the lace that she has? We are going to use the same algorithm, the same logical step. Of course, we're going to add half a meter. We're going to say half a meter, half a meter, half a meter, half a meter, half a meter 5 times, and we will get 5 halves, which is the same as 2.5 meters total. However, we are in 5th grade, and we are not going to do repeated addition. We are going to do multiplication, just like here. We said 2 meters each, taken 5 times. We got 10 meters. We're going to multiply, and I'm going to write it right here. We're going to multiply 5 times. Take 5 times a piece. That's a half a meter long, and just like it's repeated addition, right? 1/2 plus 1/2 plus 1/2, all 5 times. We will get 5 halves of meter, which is equivalent to 2.5 meters long. So here we go, my friends. Today we're going to practice how to translate word problems and solve them with the use of multiplication when we do have some fractional pieces. We have one more way to a different word problem, different context, even though mathematically works out to be the same. Monique has a piece of ribbon that is 5 meters long. Again, she has a piece of ribbon that is 5 meters long. You see, it's from here all the way to here. Let me just do a different way. Right here. This is her. This is her piece. Oh, this is her piece. This is her piece. How long is a half of the total length? How long is a half? Well, we know that to find a half means to divide by 2, correct? To find a half means to divide by 2. So we just need to split 5 meters into 2 equal parts. So watch mathematically how it works out. A half of 5 is same thing as 1/2 times 5. A half of 5 in mathematics translates to take a half of 5 meters, or take 5 and divide it into 2 equal parts. And again, mathematically, we work out to be the same, 2.5 meters. 2.5 meters. Okay. A third word problem about Andy, not Monique and her lace. Now we have Andy. Listen to this word problem. Also a familiar word problem to us from 3rd grade. Andy has a rug that measures 5 meters. That measures 5 meters by half a meter. Oh, sorry. No, that's 1 meter. By half a meter. Okay. So that's Andy's rug. That is Andy's rug. Okay. It's only 5 by half. What is the area of this rug? Well, my friends, we recall from 3rd grade that area is length times width. In this case, we don't have a whole number for our width. Let's label it. Let's label our width. This is our width, and this is our length. That equals 5 meters, and width is a half a meter. But the way we solve for area is the same, right? Area equals length times width, which is 5 times a half, which gives us 5 halves, or 2.5 meters squared. Okay, so we've seen the geometry problem when we look for area, where we multiply. Another use case, another word problem. Shayla has 5 spools of thread. 1, 2, 3, 4, 5 spools. She uses half of them. She uses a half of them to sew a dress. How many spools of thread did she use? Well, it's kind of difficult to divide 5 spools of threads into 2 equal parts, right? To find a half means to divide by 2. But let's try to do this, okay? Let's try to do this. So maybe this would be a half and this would be a half, but mathematically, a half of 5 translates into multiplying by a fraction, right? It's the same as multiplication by a fraction. To find a half of something means to multiply by 1/2 or to divide by 2. And again, we're faced with the same mathematical statement, 1/2 times 5, which is 5/2. And of course, it's 2.5 spools of thread that Shayla will use, which is right here. We have 1, 2, I don't know, maybe a half. Doesn't look like 2.5, but sure, let's move on. And now we have just various ways of finding products. We know product means multiplication. So when we're looking for multiplication, or when we're looking for products, we are just multiplying, right? So what is the product of 2/3 and 4? Well, we write it like this, 4 times 2/3, right? 4 times 2/3. It's 2/3 plus 2/3. I mean, I'm still going to use my example for repeated addition because that's what multiplication is. We take 2/3 4 times, right? Oh, okay. How do we multiply fractions with the same denominator? We just add up the numerators, right? 2 plus 2 plus 2 will give us 8/3, which is the same as 2 and 2/3. 2 and 2/3. Okay. Now, of course, we can use different methods, but we're not going to dive into too many methods right now. Let's just move on and explore different examples. Well, let's look at the circles. Again, what is 2/3 of 4? Let me write it down in English. 2/3 of 4, right? 2/3 of 4, it is... we first find 1/3. Here it is. Here we go. So sorry. Right here. 2/3 of 4, right? So the whole number bar is 4. We need to split it into 3 equal parts. 3 equal parts and take 2 of them. Whichever way you look at it, it is still 2/3 times 4. And finally, we have one more method, but I'm going to skip this method and I'm going to go again into word problems. Skip the examples. I am on page number 80. I'm on page number 80 in our textbook, 5A, and we're practicing multiple ways of multiplication fraction. Li Hua, I'm on number 2. Li Hua bought 12 eggs, 1 dozen. She used 2/3 of them, 2/3. So imagine, this is her total of 12 eggs. Did she use all of them? No. Did she use 2 of them? No. She used 2 out of 3 equal parts. So here we have 1 out of 3, 1 out of 3, 1 out of 3. And what about Li Hua? She used 1/3, 2/3 of 12. Well, my friends, let's take a look. 12 eggs split into 3 equal parts. Inside each unit is 4 eggs, 4 eggs, 4 eggs, and she used 2 of those units. Therefore, she used 8 eggs. 2/3 of 12, right? 1/3 is 4 eggs, 4 eggs, 4 eggs, and 2/3 of 12 gives you 8 eggs. She used 8 eggs. Okay, here's another method using number bar, just bar method, which I just showed you upstairs. Again, 12 represents the whole thing. We have 2/3, which means the whole thing was divided into 3 equal parts. Each unit must have been 12 divided by 4. 1 unit is 4 eggs. Let's label 4, 4, 4. But we don't need 1 unit. We need 2/3 of 12, and therefore it is 8. 2/3 of 12 in mathematics translates to 2/3 times 12. Here we go. we have another way of looking at it, yet third way of looking at the egg problem. And of course, 2 times 12, right? Let's multiply. We have 24 thirds, which is the same as 8 eggs. Two different ways of looking at it, but providing the same solution. Now we're going to look at very multiple ways to represent multiplication of fractions. Let's take a look at next following page 81. Page 81, right? I'm on page 81, friends. Now I want to show you, I want to demonstrate to you. Find the value of 1/4 of 5. That's for number 3. Number 4, right? This is number 3. Number 4, find the value of 3/4 of 5. And for number 5, find the value of 3/4 of 9. All similar problems when we're looking for parts of a whole, of a greater whole in this case, right? We're looking for 1/4 of 5. We're looking for 3/4 of 5. We're looking for 3/4 of 9. Let's take a look at how we do this. Again, I don't want to show too many ways of doing this, but I want to emphasize that when we are looking at a part of something, a part of something, a part of something, a part of something, we are, in mathematical terms, we're actually translating it into multiplication, multiplication by fraction, multiplication by a fraction, okay? So what is 1/4 of 5? Well, we have, where's my rectangle tool, right? Maybe I can do it like this. My rectangle tool. We have 5 pink circles, and we need to split it into 4 equal parts. Well, it's not too difficult, I think. Let's go. 1, 2, 3, 4, right? So that's one part, one part, one part, one part. What do we do with the remaining fifth? We don't say remainder 5. We split it into 4 equal parts again, right? We're splitting it into fourths, into quarters, and therefore each group will have 1 1/4, 1 1/4, 1 1/4. Okay, my friends, 1/4 of 5 results in 5/4, which is the same as 1 1/4, which is exactly what we have represented in this drawing. Okay, actually, they solved it this way. Let's jump to number 4. Let's jump to number 4. Example number 4. Find the value of 3/4 of 5. 3/4 of 5. Again, we have 5 circles, right? But we translate it into multiplication. I don't want you to kind of worry about circles anymore or bars. Let's jump straight to mathematics. 3/4 of 5 means 3/4, 3/4, 3/4 5 times. It's repeated addition. We will get 15 quarters. And 15 quarters, let's convert this fraction into mixed number. 4 goes into 15 3 times, and 12, and 3/4 will be remaining. 3 times 4 is 12, plus 3, yeah, and 3/4 will be remaining. Sometimes I have to check my math for third grade. 3 3/4. Now, problem number 5. Find the value of 3/4 of 9. Again, don't worry about the drawings. Let's jump straight to the mathematics. 3/4 of something means translates to multiplication. 3/4, 3/4, 3/4, 3/4. Obviously, we're adding repeatedly 9 times. We will get 3 times 9, 27 quarters altogether. And 27 quarters is 4 goes into 27 6 times, and 3/4 will be remaining. So that is what we're going to get. Okay, now let's continue practicing. Let's flip to page 82. Page 82. Again, look at numbers 6 and 7. Find the value of 2/3 of 5. Find the value of 3/8 of 20, okay? Let's look at these methods. Let's look at these examples. 2/3 of 5, right? It's 2/3, 2/3, 2/3 5 times. That means 2 times 5, we will get 10/3. And of course, 10/3 is the same as 3 and 1/3, okay? By the way, let's not forget that commutative property applies to all multiplication and addition. Of course, multiplication is addition, therefore the same rules apply as to addition. We can multiply it the other way. 5 times 2/3, whether it's 2/3 times 5 or 5 times 2/3, we still have the same solution, right? We're multiplying 2/3 5 times, and we end up with 10/3, which is the same as 3 and 1/3. These are the same, right? The same, because of the commutative property. Now, number 7. I am on number 7. Let me make a little divider line. I'm on number 7. Find the value of 3/8 of 20. Well, I hope you're getting used to the idea, right? 3/8 of 20. Of course, it's multiplication. That means we take 3/8 20 times. 20 times. And we have 3 times 20, which result in 60 out of 8. 68. 8 goes into 60 7 lovely times. 7 times, of course, we have to always simplify, and then 4/8 will be remaining, which is the same as 7 and 1/2. So that's our answer. My friends, I want to bring your attention to something very, very important going forward. I would say this is very important. You can write it in your books. Important. Important. That's when I turn on my Russian accent with 2 exclamation points. I want to bring your attention to another way of performing this multiplication. I hope we're used to multiplying the numerator a certain number of times, 2 times 5, 3 times 20, and so on. But I want to bring your attention to how we can simplify. Simplify by reducing the fraction first. Simplify our math by reducing first. Reducing our fraction first. Simplify before we multiply. So let's take a look at the same example, 3/8 times 20. My friends, if we write it down like this, let me actually rewrite it, okay? So it's nice and clean. Let me rewrite it. Oops, where's my eraser? Right here. I'm going to rewrite it. So 3 times 8, 3/8 times 20 is the same as 3 times 20 over 8. Please, let's first find a way to reduce the numerator and the denominator, see numerator on the top, denominator on the bottom, by a common factor. And what do we notice? We have 20 and 8. And both 20 and 8 are divisible by 4. Divisible by 4. Let's reduce it and rewrite it. This would be the same as 3 times, 20 divided by 4 is 5, 8 divided by 4 is 2. This is equivalent statement. Equivalent. All we've done, we just reduced 20 and 8 by a common factor of 4. And our math is much easier. Easy math. Because of that. Easy math because of that. We now have 15 divided by 2, which is of course the same answer as 7 and a half, right? So it's the same 7 and a half in both of these methods because they result in the same answer. Again, this is very important. This is very important because we learned to simplify. Simplify your fraction by finding common factors first. Simplify your numerator and denominator by dividing by a common factor. Reduce your fraction. Reduce your fraction first to give you easier math. Let's jump to page 83 and practice. On page 83, we have a wonderful, wonderful collection of examples. I would say number 8. Number 8 has many examples. Number 8 has many examples. So let's take a look. I would like to focus the rest of our lesson just by this box, C, F, I, and L. Okay, let's just look at the last column. So let's start. 3/4 times 18. First, let's rewrite it as we normally would. We would multiply 3 18 times because we're adding 3/4 18 times. Well, let's take a look. Of course, we can say 3 times 18. That will be 48, I believe, and then divide by 4, which is not that difficult. We can do that. 3 times 18, 48. No, 3 times 18, 30 plus 24. Oh, Miss Natasha, always mistakes. 54/4. And 54/4, well, 4 goes into 54 13 times, and it reduces to 13.5. Okay? Not bad. Not bad, not bad. I would not say it's too difficult. Let's take a look at example 8. I'm sorry, F for Freddy. We have 20 times 3/8. Well, let's rewrite it. It's 20 times 3/8, like that. Now, it's not so bad for us to say 20 times 3 equals 60, and 68, well, 8 goes into 60 how many times? 7 times, and 1/2 as remainder. Let me write it down right here. 7 and 1/2 would be the answer here. Okay, I'm running out of space. Now, maybe I can bump it up so I can give myself more room. Very good. Let's take a look at example I for igloo. 11/4 times 10. Of course, we can say 11/4, right? Let's rewrite it. 11 times 10 over 4. And we have 110 over 4, and I will let you simplify it. My friends, number L is a little bit more difficult. Take a look at the numbers. In fact, I want to solve the bottom line. And using the method we went over before on the previous page, simplify. You can write it down on top. Simplify before you multiply. Exclamation sign. Okay, so let's first rewrite. Let's start with J, JKL in that particular order. So let's rewrite 15 times 7/3 would be 15 times 7 over 3, right? Now, notice that 15 times 7, you might not find it hard, but for me, the numbers are getting bigger. You know I'm making mistakes when I multiply double digit times double digit. Let's look at what we can cancel out, what we can reduce between the numerator and denominator. We have 15 and we have 3. Both have common factor of 3. Let's go 3 divide by 3 and 15 divide by 3. It will give us an equivalent fraction, 5 times 7 over 3, which results, no, over 1. I'm so sorry, friends, over 1. Now look how easy it is. 5 times 7 equals 35. Example J simplifies down to a whole beautiful number 35. Let's take a look at K. 21 times 11/9. Well, let's rewrite it. 21 times 11 over 9. Before we jump to multiplying 21 times 11 and then dividing that by 9, let's take a look. Maybe we can simplify before we multiply. What can we reduce between the numerator and denominator? Of course, 21 and 9 are both divisible by 3. So they have both greatest common factor of 3, and they can simplify, right? We can simplify, reduce these numbers down to 21 divided by 3 gives us 7. 9 divided by 3 gives us 3. And we have 77 over 3, which is much easier to do the math. Now we have, it simplifies to 25 and 2/3. 25 and 2/3. Finally, example L for love. We have, again, a quite large number. 16 times 13 out of 12 is 16 times 13 over 12. We can write it this way. Before we multiply 16 times 13, 2-digit times 2-digit, and divide it by 2-digit, let's first see how can we simplify this statement before we multiply. Let's reduce this fraction. Let's cancel things out. Let's reduce by common factors. And of course, 16 and 12 are both divisible by 4. 16 divided by 4, write it down, gives us a nice 4. 12 divided by 4 gives us a nice 3. And we are reducing our job to 14 times 13 over 3, which is the same as 52/3, and it is 17 and 1/3. Okay? My friends, I would go as far as looking at, in the same way, examples G and H. Let's take a look at G and H right above. Let's take a look at these examples. They're a little bit easier. 10/3 times 6. Well, we know that 6 and 3 are both divisible by 3. 3 divided by 3 reduces to 1. 6 divided by 3 reduces to 2. And 10 times 2 is just 20. It's just 20. Nice and easy. Easy math. Easy math. Let's look at example H for Henry. 12/5 times 25. Okay, 25 and 5, we can reduce these two numbers, right? 25 and 5 have greatest common factor of 5. 25 divided by 5 gives us 5. 5 divided by 5 gives us 1. And we're left with 12 times 5 over 1, which is 60. 60. I hope, my friends, you find this method useful. Again, our ideas are to simplify before you multiply. How do we do it? Divide by common factors, like we've just demonstrated. Now, the next example will be our last for this lesson. I'm still on page 83. Let me put a nice box around it, because I think this is quite easy. Yeah, you cannot even make a box. Boom, 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 boom. Okay, sure, let's leave it at that. Let's solve ABC. 1/4 of 80, 1/5 of 50, 2/3 of 90, 1/3 of 300, 3/4 of 400, 2/5 of 100. Let's start with A. 1/4 of 80. You have 80, and you need to find 1 out of 4 equal parts. That means to divide by 4. Inside each part will be 20. 1/5 of 50. 50 is the whole thing. We need to find 1 out of 5 equal parts, and each part will have only 10. 1/3 of 300. 300 is the whole thing, right? Here's our 300, right? 300. Let's divide it into 3 equal parts, and each unit will have 100, 100, 100. Now, let's go back to C. 2/3 of 90. I'm in C right here. Well, 1/3 of 90 is 30. We need 2 of those units, so we have 60. 3/4 of 400. Well, 1/4 of 400 is 100, and 3 of those quarters will give us 300. 2/5 of 100. Well, we know 1/5. We take 100, right? We split it into 5 equal parts. Each one will have 20, 20, 20, 20, 20, and we need 2 of them, which gives us 40, okay? Gives us 40. My friends, I hope you found this lesson useful. Multiplication of fractions by a whole number. The main idea today was to learn to simplify our fractions before we